Hello everyone and welcome to today's webinar, Big Data Governance for Complex Data Analytics, Making Unstructured Data Accessible while Enforcing Privacy and Security Policies. My name is Alex Popov. I'm a Product Marketing Manager here at FEMA Systems, and I will be your host today. FEMA makes a big data management platform with focus on data governance, privacy, and security, as well as operational simplicity. For those of you who would like to learn more about our product, we will have a short overview at the very end of the webinar after the Q&A. We'll start in a couple minutes, but first I'd like to go over a few housekeeping items. Today's webinar is going to be recorded, and we will make recording available on our website, and we'll email you the link. We'll also make our slides and the transcript of Q&A session available for those who can't wait till the very end. You will have an opportunity to submit your questions at any time during the presentation via the webinar question widget, and we'll address them during the Q&A session at the very end. And if you'd like to tweet, please use the hashtag FEMIwebinar. It's hashtag PHEMI webinar, all one word. Yeah, and you can see it on the title slide right now. And now, with logistics out of the way, I'd like to introduce today's speaker, Dr. Roy Wilds. Dr. Wilds is the Chief Data Scientist at FEMA Systems. He leads the FEMA Data Science team in helping customers extract the most insights from their data. Roy has experience leading large-scale data mining projects and helped build data protection tools for numerous data mining operations. Roy has advanced knowledge in machine learning theory and substantial expertise using Hadoop's distributed technologies. Prior to joining FEMA, Roy worked as a mathematician for the Government of Canada. And with this, I will pass the presentation to Roy. Roy, take it away.
Perfect, thank you. So good morning, good afternoon, and good evening, everybody. Thanks for dialing in and joining us today. Today we're going to talk about complex data analytics and the role that big data governance has to do with that. And so I thought I would break this down into talking about a few of the challenges that pop up in this space and start to focus in on those and what the role of governance is and how that impacts how data analytics are applied or potentially pursued during the course of an enterprise's pursuit of working with their complex data. So we'll start off talking a little bit about dark data. We'll define that and we'll walk through some of the examples, but it's really about enriching your organization by having access to more data to help either identify efficiencies, new services, or other insights that you didn't have before. Since this is a big data talk, we will talk a bit about big data platforms, some of the challenges, some of the gotchas, but a lot of the opportunities as well around what this type of technology can afford you in terms of driving business value. We'll talk about data governance in a bit more detail. It's really an underlying theme, as you can tell from the title. And one of those things that is very easy to ignore or just pay lip service to initially, but does tend to bite you down the road. So we're going to talk a little bit about why governance is critically important and really what it means you can do down the road to help keep your analytics projects accelerated and delivered in a timely manner. Right, so after talking about data governance, we'll then go into the fourth piece that we'll talk about around challenges, really dealing with PS&G, so shorthand for privacy, security, governance. And specifically, we'll talk a little bit about how taking it as a second phase or a bolt-on option down the road can lead to a lot of challenges. And the issue being there that it's really something you want to think about up front. You want to give some thought to how you're going to tackle these challenges and deal with these processes. So after talking a bit about all these challenges, opportunities, and a bit of recommendations, we're going to finish off with a few success stories, just talking a bit about how examples in the marketplace and published publicly have really been driving these situations to realize value from the complex data that can be analyzed. And then, as Alex mentioned, we'll finish up with a Q&A and a bit of a description of FEMA. So dark data, just to introduce it to those of you that have not been familiar with the term, the reality is that this data is actually most of the data that's out there in enterprises, but is not often the focus of your analytics projects or other types of traditional business intelligence and reporting. Depending on the organization, the amount of data that falls into this bucket or this category of being dark data varies across different organizations, but in a lot of cases, it's the majority. It is the vast amount of data that is present in your organization that is being stored for compliance purposes, potentially for logging or technical purposes, And while that's maybe the initial reason why you're keeping it, so you're keeping emails or you're keeping server logs, and initially you were doing that because that was just part of the standard process, again, for those compliance or technology reasons. What the leading cutting edge organizations are starting to realize is that those data sources, that dark data, can actually be mined for additional insight. This could be something such as figuring out better ways for individuals to navigate your website, rather than just keeping those web server logs just because you use them for troubleshooting when there's a technical problem. You could also look at working with communication data, perhaps, that you're experiencing with your customers, and rather than just specifically looking at email data as a communication tool so that you would reply and engage in a conversation, what if you took a look at all of that communications data to find out if there are patterns or groupings or other properties of your customer base that could be used, for instance, to impact marketing campaigns or other types of approaches like that. So it's this kind of perspective on dark data that has really led, a lot of analysts out there to start talking about data being the new oil. This is the data that is still lying underground, is not quite available yet, and is going to be the source of data that's going to drive some of the new innovations over the next 5 to 10 years. So when we talk a bit about recommendations and how to deal with these specific challenges and what can dark data enable your organization to do, so we talked a bit about the value. How do you realize this? Some of the recommendations that we see in the marketplace and that we advocate for ourselves, start off by figuring out how you're going to organize and protect this data. All too often, dark data, documents, images, reports, all of that kind of data as often has pieces of sensitivity embedded in it. Again, if you think of the example of an email, you have personal information potentially embedded in that email. So you need to take account for the challenge of around protecting that data. The second piece is organizing it too. So it's very easy just to take a bunch of files and dump them into a file repository, and then task one person or two people to go and start analyzing it. This doesn't scale. It doesn't scale as your data volumes grow. It doesn't scale as the number of users that want to be working on that data grow. And it doesn't scale as you start to add more and more types of this data. So you want to give a lot of thought to how you're going to organize and protect this data up front. Because as soon as you start realizing successes, and again, this data often is a source of success for initial projects and pilots, because you are able to find those insights from that data. You don't want to be a victim of your success and then having to deal with those problems down the road. You want to give some thought to it up front. One of the best ways we found for individuals and organizations to really unlock that value, so extracting the structured information from this dark data. So this could be things like understanding customer sentiment. It could be examples such as finding out about efficiencies and processes and other types of metrics that eventually are going to drive business decisions. Having SME, subject matter expert, involved is of key importance here. You don't want to spend and waste too much time having generic individuals going through this data just because that's what their usual job is. You want to make sure you engage with the people who understand this data, and it's going to help you drive value a whole lot faster. And the theme, as you see in the bold at the bottom, applying a strict data protection and governance discipline throughout. You really want to have that applied in this case to not just to the data you're storing in the first place, so your documents and dark data, but also to the data you're going to be extracting from it. So for instance, if you're taking in email data and you're producing some sort of keyword summaries or types of metrics that might be measuring the happiness or the dissatisfaction of that customer, that additional data, those data sets that you're creating from that dark data, you want to make sure you're applying governance to it as well. Otherwise, it's going to become part of that mess down the road, and you're going to have to deal with the problem in different ways that often can be very costly and also lead to slowdowns in projects down the road. A bit about big data platforms. So there's no shortage of technologies and different types of software projects out there that fall into the big data platform. We often encounter in the big data space the two most primary kind of groupings of technology, if you will, fall into the Hadoop and NoSQL space. And there's a whole slew of specific projects and flavors down within there. The important thing to keep in mind is that these technologies are often necessary for dealing with complex data, especially at scale. The old traditional technologies of the 1990s, 80s, and early 2000s even are not often well suited for dealing with the sheer volume and variety of the data you're working with here. Often down the road, you can start to go with hybrid systems that allow you to mesh these two different pieces of technology together as you see fit. But to start with, working with something like Hadoop or NoSQL systems is a great starting point because of the flexibility, the capacity to scale, and some of the agility in which how you can work with this data. It's worth keeping in mind that some of the challenges of working in these technologies too, though, pop up from the fact that they're very new. So Hadoop has been around since late 2000s. NoSQL systems, depending on which flavor you're talking about, for a bit less, a bit more. And so it's worth keeping in mind how you want to use these technologies. It's all too easy to start with this technology, just get going, start playing around with it, and then have trouble down the road in terms of actually productionizing it or rolling it out into a more robust situation. Just as an example, for instance, in the Hadoop ecosystem, most of the standard packagings that are out there from vendors such as Hortonworks or Cloudera or MapR come with 20+ projects within them. And that's fantastic power and flexibility, but also inherent complexity and risks to start with. You want to be very careful about how you're tackling those technologies and making sure that you're making the right choices to meet all of your governance and protection needs in dealing with this data. A little bit about recommendations. Again, the same thing that we're talking about throughout around data governance and protections. You want to consider this from day one. You want to make sure you're thinking about this. How are you going to deal with it? How is it going to play out down the road as you start to roll out these solutions? You can make different choices for your first couple of use cases depending on how you want to prioritize your resources and what the important deliverables are. But the one thing we really advocate for is do not delay those decisions or those tough conversations too far down the road, or else it really becomes a problem in terms of dealing with these challenges if you don't factor them in until later on down the road. In dealing with this big data technology platform ecosystem, there's a whole lot of tools and choices, as I mentioned, 20+ different software projects that come available in these systems. And so how to choose, how to focus in on which specific technologies to use and how to tie them together and what kind of an experience to deliver to your analysts, your data scientists, whoever is going to be working with this data. It really helps to identify those priority workflows and personas early on. They will almost inevitably grow into more varied and complex scenarios as you start to realize success. But to start with, it really helps if you've got a few key people and workflows you can focus in on to help drive those decisions and make sure that you are configuring and protecting and setting up your system in the right way. The last piece I'll just touch on here, cloud is everywhere these days, depending on your industry and your specific location and regulations and everything else. It can be a decision of whether or not if that's a proper decision for you to make versus the on-premise decision. The one piece I'll just mention here is that 4 or 5 years ago, it was not too big of a decision to make. On-premise systems, bare hardware had a big performance advantage. Nowadays, that really has started to disappear. So you have the flexibility of choosing, do you want a cloud deployment for your big data system, or do you want to have something on-premise? And both choices have their pros and cons, but it's become a much more even decision to make without that negative aspect of all the performance that used to be present in the technology space. Data governance. So data governance really comes down to what is your approach to dealing with all of the data you have in your enterprise. And what we're going to focus on here is really how it impacts in a big data system that's going to help enable you to do your complex data analytics. So the challenge that often pops up in these situations, and I've touched on it earlier, is that there are tons of different types of data that are going to be present in your enterprise. And in many cases, not just in your own business, but also in the surround, in the other types of services or interaction channels that you have to factor in. And I've just got a whole mashup of a bunch of different types of examples up here. Some will, some won't apply to your specific industry. One example, for instance, that often does touch a lot of companies, social media. Back in the day of having a limited number of service channels, you might have individuals only interacting with you through email, through phone, and potentially in person. And now we're in a situation where people will tweet at you, they will contact you on Facebook and post their comments and what they think of you over those different social media systems. And so having a way to tie that data in, not just in a customer service experience, but also being able to use that information analytically so you can understand the sentiment or the perception that your customer base has, or how to potentially tie that into your complete picture, the 360-degree view of the customer, becomes very important. We're moving into where IoT is moving past the phase of being a lot of buzz and really into implementation. So devices are everywhere. There's tons of other sources of this data that can impact in your organization, and how you want to govern that data. So how do you want to make sure that data is useful to you so that downstream individuals, not the ones that are necessarily collecting and experts in that data, can still benefit from it by being able to use it in their analytical processes. That's the real challenge around governance of data in these situations. So again, similar theme. When we're dealing with all these different types of data, the governance and protections are absolutely core to the successful adoption of this data and being able to tie it into your analytics realm so that you can actually benefit from this information. Understanding what the data is, where it is, how it's being put into the system, what the sensitivities are, all of those things reduce friction down the road as you actually move into the stage of wanting to find patterns or answer questions of data, not having to go back and figure this out after the fact or having to rediscover it every time someone goes to work with data. It's a huge advantage in productivity. Closely related, dealing with data protection. So this is the challenge around dealing with the privacy aspect of data, dealing with the security aspect of the systems in which this is being stored. And this is often a situation that doesn't get quite the level of attention it probably should in situations where you're starting off in a pilot or initial project involving applying complex data analytics in a big data environment. And the reason we really call it out here specifically is that often when you're dealing with the dark data, and I mentioned it earlier, it's highly sensitive data. It has a lot of sensitivities in it that you want to make sure you're accounting for when you start to try to unlock it. And just because it's got sensitivities in it doesn't mean you shouldn't try to benefit from your business in terms of having that insight into your business processes or your customers. But you want to make sure you're not just paying lip service to the requirements around dealing with the private nature of that data and making sure that you have a secure system in the proper way. So from a privacy and security perspective, some of the biggest challenges pop up when you start dealing with the fact that in a big data environment, there are tons of different projects. The ecosystem can be complicated. People like to use their own tooling. And how are you going to tackle that as an organization so that at the end of the day, whoever is responsible for that risk and compliance around these technology systems is going to be satisfied with the approach you've taken. And here, just like we talked about in terms of reducing the complexity of your big data platform, from a security point of view, also identifying those early priority workflows and personas help you to really structure and tune how you want to tackle the challenges around privacy and security in terms of actually how you're going to configure the system. How are you going to lock things down? What types of access will be permitted? How do I want to allow these users to work with the system? And that could be much more focused, much more productive if we start focusing in on some specific workflows and personas at the beginning. The second piece is don't lose sight of the long game. So don't only build something that works for use case 1 and 2. We see this type of approach that often results in failure a bit too often, especially when sensitive data is involved. You want to make sure you're factoring in how am I going to deal with use cases 10 plus? Because if we're successful here, the last thing you want to have happen is have a whole bunch of roadblocks thrown up that are barriers to actually adopting this technology and pushing it into new business areas as you start to see success in these different scenarios. So that's a brief walkthrough of some of the challenges, some of the opportunities, some recommendations based on what we've seen in the marketplace and our own experiences in dealing with our customers. I just wanted to walk through a couple of examples of some successes that have taken place in the big data and complex analytics space. So I'll walk through these briefly, but just to touch on before I jump into those, I wanted to just reaffirm that this is our perspective, this is what we see, but this is also what's commonly seen across the industry. So what these two different charts are showing you essentially is that dealing with governance issues, dealing with security, dealing with challenges around not having enough expertise in the technology to feel confident in using it and making sure it's secure, these are the top challenges that different organizations face. And so this is representative of what we are seeing in the industry and is reflective of the kinds of challenges that if you're undertaking your first couple of big data projects or working in dark data and complex analytics, this is the kind of challenges that you're likely to also encounter, and knowing about it in advance is a huge asset. So back to those success stories. The first one we'll talk about here, this is an example from Walmart. This is being publicly published, and so something you can easily look for if you want to do a search for Pop-Tarts and Walmart with hurricanes. What this analysis did was Walmart did an analysis of their sales data, looking across all their different regions and looking at what kind of products were selling in different types of temporal patterns as well as different other types of external factors. And so that's traditional inside the company, normal data. Everybody has their sales transactions data, and a lot of people do fantastic reporting on it. In this particular case, Walmart decided to bring in an external data source. So again, going back to that slide of all that variety, they decided to bring in some weather information as well as geographical location data that allowed them to identify what was going on in the outside environment and correlate that information, that new data, with the internal sales information they had. And what they identified is that it turns out there's a huge spike in strawberry Pop-Tart sales right before hurricanes make landfall. When you think about it, and they did do the analysis diving into the reasons behind it, it actually makes a lot of sense. Turns out Pop-Tarts are very good at staying fresh for a long period of time, don't require any heat to actually be edible, et cetera, et cetera. A lot of reasons why this is the case. And they were able to use this new insight by combining that external varied source of data from that weather information together with their internal sales structure data to be able to figure out we should be stocking up these things in addition to just our normal stocking plan in the event that hurricane season is approaching or other types of triggers that allow them to deal with it, so they're not having a situation of being sold out. A very simple example, but again, very powerful example of how combining data in new ways and then applying these data analytics procedures can allow us to find new patterns in the data. The second example is one I really enjoy, and this work has really gone in a ton of different directions, and so it's fantastic. And again, I encourage people to look it up and to dive into it more if you're interested in the story. It's based in New York City. In this case here, the core problem they had is that building inspections were only so efficient in terms of actually dealing with the problem cases that are present in the city. So you have a finite number of inspectors, they can only do so many inspections. And so the challenge that was sort of the basis for this approach was, how can we make those inspectors more efficient? Because it turns out a lot of the times they go to inspect a building, it turns out to not really have needed inspection, or it passes and there's no concern to have. And what they wanted to do was to increase the number of high vulnerable or buildings that do represent a fire risk as being more frequently inspected. So in this case here, the New York City Department decided to go and tie together a bunch of different sources of data. In this case here, some of the complex data that they were dealing with corresponded to information and submissions from the citizens of the city. So actually having the data that individuals would send in either through complaints or through other types of standard reporting. So this was a new source of data they had not used previously to mine for analytical purposes. They had previously just used it as being, okay, we'll put this in the queue and we'll use this as a priority to determine if someone should go look at it. But applying data analytics to this complex data, they were able to combine that with other information, such as, for instance, permits that were put in around the buildings in the system, other things around, past inspections and other types of factors, that when they combined all this data together and did the analytics on this data, they were then able to identify, okay, this is the prioritization of which kinds of buildings we should be sending our inspectors to. And they drastically increased their success rate of finding individual buildings that should be actually inspected because they were in a hazardous state. And most of this work was possible because they took the time to make sure that they could actually have the proper understanding of their data and be able to tie this together. All too often you hear these success stories and the end product sounds amazing, but you don't necessarily get a full sense of how much work and effort and sweat goes into the actual production of the actual data to drive this kind of analytic. But you see the value here in terms of the kinds of things that are possible. Last one we'll touch on is just related to healthcare. So on the left-hand side, we see our classic picture of an Amazon-type buying situation. And one of the great things that Amazon has really driven is this whole notion of recommender systems, which is basically a data analytic that allows you to recommend other things you might be interested in based on the browsing habits of what you're looking at. So in this case here, I'm looking at a camera. I see the other types of things that people are interested in. Fantastic from a retail and commercial opportunity. But what we're seeing is that this type of approach is also being applied in other domains. And one really fascinating space where this is going on is in precision medicine. So precision medicine is really focused on the challenge of how can I use all of the detailed information available to me about you as a patient to determine how you should be treated in various situations. So this is using data such as your genome and looking for different mutations and types of changes there. It's dealing with your family history, prescription, your lab results, detailing your blood chemistry, and all these other types of data. And while that data in and of itself is interesting, it tells me something about you, and I can use that information as a physician to determine how should I be structuring your treatment plan if you end up getting sick, or maybe in a preventative measure to keep you from getting sick. One of the big gaps today is not having the ability to say, I have all of this data, there's so much of it, but what are you like? Can I take this data and use it as a reference point so I can identify other individuals that are similar. Because if you go back in the history, the way a lot of medicine and a lot of therapeutic treatments are developed is by looking at groups of people that are similar, and you can understand how somebody has responded to various different treatments, and then use that to generalize to understand how to treat a population. So the power here being, if I go in, I have a test done, maybe because I'm at risk of some disease, they potentially could use that information to identify other individuals that have been treated in the past or are currently undergoing procedures to determine what should be done with me and how should I be treated. So that takes us to the end of the session in terms of the presentation. I hope you found it interesting and learned something new today. Now we'll open it up for some questions if anybody has any to enter into the Q&A panel.
Thank you, Roy. We're just going to give a few more minutes. That we already have a few questions that came in that you should be able to see on your screen and in the questions widget, Roy. I'll give you a little time to look through them and prepare. And at this time, I'm just going to encourage more people to submit. If you have any questions about this talk or the subject, please type them into the questions widget.
Perfect. So yeah, we do have a few questions here in the queue, so let's try and get through a few of them. First question here, what are the primary ethical considerations in looking at data governance for big analytic electronic health data? That's a fantastic question. So anytime you're dealing with sensitive data, of which electronic health data is a prime example of some of the sensitivities that can exist, ethical considerations do come into it. We don't often encounter the situation where the technology itself is a cause or a concern factor for the ethical aspect of it. It's more so the types of questions being asked and how you're using those answers. So our recommendations and what we often see in the marketplace is, focusing in on what kinds of questions are important and how are they going to be applied in the situation. So the ethics really does come down to, again, the individual that's doing the data analysis and how are they going to work with that. There are plenty of examples out there in terms of inadvertent racial profiling or accidentally or unintentionally identifying potentially high-risk groups of health patients that otherwise may be being profiled or grouped using, with a connection to another variable that you did not intend to have. So I guess the short answer being that there are a ton of different types of considerations to be considered from the ethical perspective. It depends on the specific space you're in, but it's really something that has to be tackled on a specific case-by-case basis. Again, with the person that's doing the analysis being the primary person that's responsible for making sure those get answered and get addressed in the proper way. Another question just came in. Can Hadoop or big data exist with my enterprise data warehouse and analytics tools? That's a good question. It's a common question we encounter. So there's really no this or that approach when it comes to big data for analytical purposes. The most common situation we've encountered is really a case where big data analytics, such as Hadoop, for instance, as a platform, help to augment your existing system. So it's not so much about replacement. It's really about having a net new capability. And if you think about the examples we talked about with the dark data, for instance, that really is an example where that data from an analytical purpose is not currently being used in your existing data warehouse systems, or if it is, it's typically being used very, very lightly. And so there's an opportunity to really deploy a new technology that allows you to work with this data in new ways and augment that overall perspective. So it's very much a positive sum game as opposed to a zero-sum game. From an analytical tool perspective, most of the tools that are out there, such as your drag and drop or your wizards that allow you to work with your analytical data, many of them do work with big data environments. Specifically, I'm thinking of Hadoop. It has a bunch of the connectors and plugins necessary to do that. So again, depending on what your specific tool set is, it often can work with that environment. Although I would draw attention to the fact that there's also new types of analytics that are available that can be used in new ways. So there's always an opportunity to grow your capability at an organization without having to only work with the tools you had previously. Again, that additive effect as opposed to a replacement effect. Another question came in. My company is debating between cloud versus on-premise. Any comments? Probably many comments. I would start by commenting that, as mentioned earlier, often this decision comes down to more than just simple fiscal decisions in terms of what's the lowest cost, what's the best decision. There's often factors that come into play, such as regulatory factors, data residency factors, and other things like that that can supersede this. But the generic comment I would make is that cloud is a fantastic place to do initial evaluations of how you want to use a new technology. And as mentioned earlier, really with the cloud at the state it is right now in terms of its support underneath at the technical level for being able to deploy big data systems such as Hadoop, it's a very cost-effective way to start out without having to make a massive investment in hardware initially or having to plan that through your typical CapEx type operation. Having an operating expense approach to this really does make it lower barrier to get involved, get working with, and also to be able to scale in the future as your organization grows. One more question we've got here. I keep reading that big data projects get stalled after the pilot. What's preventing these projects from making it to production? Well, depends on the specific circumstances. That's certainly the case there. So there could be a myriad of reasons why, but the most common reasons we encounter, and you saw it in that graphic I showed up briefly before we jumped into the success stories, a lot of the factors that do slow this down is dealing with the security and privacy aspect after the pilot. We find that that's a barrier to a lot of widespread production deployments in many situations, just because, again, it's very difficult in these spaces and working with these technologies to bolt on a security solution after the fact. You really want to be factoring in at the beginning. It becomes much simpler, much easier for you to continue to enhance and grow that. Again, security is never over. It's a constant process, but doing it early on as opposed to post-pilot tends to prevent that being the stalling reason. The second factor we do see is again related to governance. So once you have a successful pilot, is all of that knowledge about that data that was used to derive and deliver that business outcome, and assuming that business outcome was successful, so you demonstrated some sort of ROI. So maybe you showed that there was possible for reducing the cost of some business service, or identifying a way to engage more effectively with customers, which was going to drive net new revenue. Once you've found out that end deliverable, you want to make sure that all the information, all the cataloging, all the understanding of data you did along the way isn't lost just in that outcome, because it's that same context and understanding of your data that's going to help to drive the eventual solution down the road for the other types of situations. So you can build off of that as opposed to always starting from zero. It's a very powerful capability to have. One more question here. This is a little bit of a long one, but at the federal level, it is difficult for an agency to access siloed data possessed by another agency due to security and privacy regulations. What are your thoughts about de-siloing data when doing so poses severe risk to protection of sensitive information? That's a fantastic question. It's one of these cases where it certainly is true that there's always this tension that exists between having data siloed and protected versus the ability to have it put together so you can ask analytical questions about it. I guess my thoughts on the de-siloing of data and how that can potentially pose a severe risk to the protection of that sensitive information, you have to do it the right way. So there are standard procedures that are out there to help de-risk these situations. So things like stripping of unique identifiers and replacing them with pseudo-identifiers. So if I'm going to pull together data from Ministry A and Ministry B and put it into a common pot, if you will, or repository for doing analysis on it, I want to strip out those identifiers. I want to replace it with something that can still be used to link data, but not necessarily reveal the underlying identity of an individual. That takes you part of the way there. It doesn't get you all the way there for sure. You still have things like re-identification risk, where having enough data allows me to identify who somebody might be. But again, there are mitigation strategies for that as well. So you can do things like standard techniques for doing the re-identification risk of a data set, so that you can purposely blur or fuzz out the content of that data to de-risk the privacy consequences of it. Again, there's a trade-off there in terms of the analytical power of that data, but it does at least give you a dial, if you will, that allows you to set what level of potential privacy sensitive data access am I willing to accommodate in order to be able to have the protections necessary but still get that analytical power. The last piece I'll just mention about is, in these situations here, we're often not talking about a case where these data sets or these analytics being done are in the public domain. Often this is within a specific domain, whether it's a federal government domain or within a single business. And so having the confidence and the ability to understand what are your users doing with that data, So, having things like audit capability, so you know what they've done as part of the process. And again, it's really that thing to have that confidence and that proof point that indeed these people were following the proper procedures, you had confidence that they were doing what they were supposed to, and you can prove that effect. These are often the kinds of extra pieces that are very important in being able to determine that, again, in dealing with sensitive data, it's being used in the right ways. If I take the example of, you look at what clinicians and physicians do with healthcare data all the time, they use it in the way they're supposed to make sure that you get delivered proper care. That's very sensitive data, but when used in the proper way is a fantastic benefit. For those of us that can remember having paper charts back in the day, it is fantastic having electronic medical record systems now because of how much more accurate, portable, and on-demand they are. And this is just one example where you have to be cognizant of those privacy considerations. You have to make sure you're dealing with sensitive data properly, but you can still do a lot of great things by making sure you're doing those in the right way. Great question. Another question just came in. Don't you have to have a team of data scientists and Hadoop people in your company to successfully implement a project? This is often the question we get. So it is true, it's a new technology stack. And certainly there are challenges in terms of how to deal with that and what you can do with it, depending on the specific talent or technical capability you have within your organization. The generic thing that I tend to say to this question is, to start with, you have tools and vendors out there that tend to reduce the complexity of the underlying Hadoop system. Going technical for 1 second here, is a situation of like installing a Linux server, for instance, that's running your website. Not everybody goes and actually works at the level of a Linux server. You can work with a vendor that provides a website that you can actually work with. And so those different levels of abstraction also exist in the big data space. Alex will talk a bit about what we do at FEMI, which is in line with that as well, but there are plenty of options that are out there that allow you to abstract away the complexity. You can always go into it later on if you want to, if that's where your organization wants to go as you start to grow, but you don't have to start there. You can start with a prepackaged system that's fully integrated, has all the security in place, that you can connect in your analytical tools that are your drag and drop ones you're used to, and you can start there. Again, that's what your personas and your workflows dictate as being the initial priority. And you can always grow in different directions. You can start to train individuals in-house, or you can work with partners, or there's tons of ways to start to grow. But there are ways to get started with big data without having to have all of that highly technical capability, so you can still start to realize those initial points of value. One more question here. How mature in your experience is the current state of natural language processing technologies available on Hadoop? How mature? That's a good question. So at this point right now, there's a lot of tooling available out there. There's not a whole lot of point and click, drag and drop type capability, at least not that I've encountered. And again, I've got a perspective on a specific slice of the space, but haven't encountered a whole lot of tooling that's just ready to go out of the box and automatic. There certainly is a lot of tooling that's present, but it's, again, very low-level tooling. So you want to either find a vendor who has those capabilities that has started to integrate them and make them available for you to just work with, or else you want to have that capability to actually start to grow and build on those technologies yourself. And again, there's a lot of fantastic technology, especially in the open source space, as a starting point to work on that. Another question just came in. Should the data cleanser be familiar with the product in order to have successful data? I guess I would answer that in a couple of ways. So the first one I would mention is going back to the comments I made about the dark data and the recommendations. Having a subject matter expert, someone who's familiar with the data, is absolutely integral to being productive and efficient in unlocking complex data. And cleansing is a part of that. Let's be clear, there's often a lot of noise and messiness, if you will, in terms of that dark data, just because often by its nature, it's highly unstructured, it's people typing into things, it's potentially image captures, it's a lot of stuff that's not highly structured, so you have to cleanse it. And so having a subject matter expert really does accelerate that process. Not necessary, but again, you can imagine not having to fish around in the dark, but having someone with a flashlight to point you to what's important and how you should be dealing with it and what it means, highly beneficial. Maybe if I answer the question in a different way in case I misinterpreted it. So if the data cleanser has to be familiar with the technologies, if you will, in order to be able to deliver successful data, you have to be competent in the technologies you're working with. And again, to my earlier point, depending on how you want to engage and who you want to engage with and what your internal skill set is, You can pick which of those kinds of pre-packaged Hadoop systems, fully integrated stacks, or potentially going to the actual core technology. You want to make sure you're productive in whatever choice you make there. So if you don't have that internal skill set, that's a bunch of Java programmers working in the Hadoop environment with knowledge of distributed systems, you can work with a fully packaged system that starts to abstract some of that complexity, so that you can effectively cleanse the data but not be blocked, if you will, because you don't have that specific technical expertise, even though you understand the data. There's a lot of ways of tackling that challenge. So I think that looks like all the questions.
Yeah, thank you, Roy, for taking the time to talk to us today and for answering the questions. There's one more question I would like to take myself. The question is, who is FEMI's biggest competitor? That's a good question. And the way I look at it, our biggest competitor is apathy and inertia. It's the status quo that we're trying to compete against. It's the customers who are still sitting undecided. They're considering, is it just a buzz? Is it a newest fad, or it's actually there's some value in this? And this often comes in two flavors. Sometimes it is really an inertia, an organizational inertia, that we've done our analytics a certain way. We have our data nicely laid out in the data warehouse. There is that other data, unstructured data, new sources of data out there, but we don't really know what to do with it, and we don't really know what value it brings to us. But there's more pragmatic point of view as well, as some people are thinking that technology is still not mature enough. There's a lot of concerns, as Roy mentioned, about having capabilities and people and processes to establish big data analytics program and actually extract value from that. And with this, we're actually trying to, with FEMI, we're trying to address those issues. We're trying to make big data simpler to use, so it's much shorter implementation time. It doesn't require as many highly skilled Hadoop engineers or programmers on staff to keep patching it and customizing to meet your need. We try to create a product that is sold as a package that you can really deploy on your infrastructure, on the choice of your infrastructure in a matter of days or a week, and get to insight within a very short time. Another really big competitor is actually our customers, is the do-it-yourself attitude. And because Hadoop is available as an open source software, you can just download it and start playing with it, and you don't have to pay a dime. And it works fine for some companies. If you're a large company with lots of technical expertise, you have developers, Java developers and stuff, people with deep understanding of distributed technologies, of modern data science tools, you can put together a really good solution for yourself. But make no mistake that you're paying for that solution one way or the other. You're either paying for a license so that some work, some grunt work is done for you, and you can concentrate on the last 20% of effort that you need to customize the solution to really drive the insights. Because the big data implementation is not about infrastructure, it's not about some fancy reports, it's not about numbers, it's about insights. So we suggest the customers focus on their domain knowledge, on the knowledge of the particular problems they're trying, particular questions they're trying to answer with that data, and leave the infrastructure and complexity of distributed computing to us. And I think it's a really good segue into our final section, where I want to give a really quick overview of what FEMI is and what is our solution. We are built on top of either on-prem or a cloud infrastructure of your choice. We support Amazon Cloud, Microsoft Azure, and Oracle Public Cloud. And it comes with the choice of whether it's fully supported and hosted by the customer, or it's a managed infrastructure managed by FEMI. On top of that infrastructure, we deployed a pre-configured and optimized and secured Hadoop distribution. And that's one of the important things that we see. A lot of do-it-yourself companies struggle with is it's relatively simple to get the system up and running, but it takes incredible amount of time and effort to properly secure it, make it PHI compliant if you're dealing with personal or health data, Kerberize it, enable encryption. It is a serious undertaking. So we provide a system that's totally fully secured and optimized. And on top of that, standard Hadoop distribution, and we support both Hortonworks distribution and Cloudera. We're certified on both. So whatever, if your company already have investment into big data solution, maybe running on Cloudera, we'll work with that distribution. So on top of that distribution, FEMA provides a data management and data governance framework with an easy-to-use user interface that simplifies the operational aspect of big data. So it's easy to set up your data ingest. It's easy to define data governance and security and privacy policies, and it's easy to operate the solution. So with this, we're basically solving a problem of easy onboarding of data. We give you tools to create the data, protect it, and consume it. So just going to go over some of the things we do. So we ingest structured, unstructured, and real-time data. Once it's ingested, it's automatically converted in what we call analytics-ready assets. And by that, we mean that in a lot of cases, especially with unstructured data, data comes in as a document. It could be a JSON document. It could be, let's say, a medical report, procedural report. It could be in the form of medical images or other data format that has a lot of data in a loosely structured way. So we break it down into individual data elements and extract that, keeping the original data document. We extract those individual elements and make them easy to use in analytics. So on top of those, on the ingested data, we provide you tools to easily define and apply privacy and security policies. So let's say we're ingesting a medical report, which has some information that is contains personal health information, personal identifiable information. So there would be different policies applied to patient's name, patient number, date of birth, and other personal identifiable elements, while keeping, let's say, diagnosis code available to broader audience. And once we apply the policies, all the data ingested in the system is indexed for quick lookup and catalog. So it's easy to find the data you're looking for. It's easy to organize it into data collection, and it's readily available. So the system, after that, the system enforces access, de-identification, and retention policies. So for example, certain data should be kept on file maybe for 5 years or 7 years. We do it automatically at the time of ingest. So the policy is assigned which says that this data set needs to be purged from the system within the 5 years. And again, because we apply our access, de-identification, and retention policies on individual data element, that could be also varied and provide different access to different parts of data. And all activities in the system are centrally logged. So it's very important from the compliance point of view, and especially in regulated industries, that there's so many different ways you can access data. It could be accessed through the user interface. It may be an API call. It may be accessed through the data science environment that comes bundled with FEMA Central. It could be accessed through some other ways. But all types of access, whether it was granted or not, is tracked in a central log, making it really easy to audit for compliance. And finally, we provide the interface to easily consume the data. So we interface with external systems and applications. Like I mentioned, we provide the data science environment, which fully respects the policies, the identification and access policies defined by system administrators. We have a complete separation of duties, so people who manage the system may not actually have access to the data. It's defined on a very granular level using visibilities and user authorizations. And if data is shared, which we come across very often in either academic environments or in case of clinical trials in healthcare, there's a lot of data sharing between the organizations. There's usually particular data sharing agreements assigned attached to any particular data collection. It's governed by consent. It's governed by the date period in which that data is available for sharing. So this is automatically enforced by this system. And that's basically, in a nutshell, very high-level overview of what we call FEMA Central Big Data Warehouse. And basically, it allows you to ingest the data from multiple sources. We ingest it from relational data sources, from traditional data warehouse or operational systems, a number of complex or unstructured data sources, including genomics data, data from medical imaging or reports, social media. We have experience working with emails and streaming data from wearables and devices. So that system gets in the system, which allows you to organize and protect the system, and then we provide an easy way to access, share, and consume this data. And with this, I am going to close today's webinar by thanking everyone who attended. We're really happy to have you here with us today. And again, we will make the recording of this webinar and the transcript of our Q&A session available to all attendees. We'll send you a link to those resources. And thank you once again, and have a great rest of your day. Thank you.